Oh, hi. It's the Mathization channel, a continuation of my last video about surface area of a sphere. Um, we derived that's equal to circumference times diameter, and that equals the well-known formula of 4 pi r squared. Okay. Um, maybe this is supposed to be like some kind of projection too. I know the surface is curved and it's longer than the diameter. It's actually half the circumference, and if you go all the way around, it's equivalent to the circumference. So, okay, so maybe a better drawing for that would be down here. So, we do have the circumference. Um, as like the, say, length and the width of each one would be a small fraction of d, and then and you would get, each one. Well, and each of those, draw these here. It could either be like that, considered each segment, or long ways here. All right, and then these are, of course, an infinite number, and that would correspond to this drawing down here. And you would just use the diameter, only go that far rather than all the way around, because when you consider the circumference, it does already go around. So you're already including that. You don't want to include that area again. So you just go the diameter, up to the diameter. So that's why we have this here formula. Another formula is okay, pi times diameter square. Okay, so 2r is the diameter. Yep. Let me check that a minute. Pi times diameter square. Yeah, it is pi times diameter squared. Let's see how we got that formula. See, 4 pi. There we go. R squared is 4 pi. Diameter divided by 2 squared, and that equals 4 pi. D squared, and then these would cancel out here, the 2 and the 4. Anyway, we get no, actually that's a 4. When that, okay, put it right there. That would cancel out, and we would get pi times diameter square. Yeah. Okay, that's where that's from. So these are equivalent. Circumference times the diameter, 4 pi r square, and pi times the diameter square. Okay. Actually, looking down upon the pole of the sphere, this is the diameter here. This would be the diameter square. See, this diameter, just equivalent to diameter. So that's that area right there, and it's actually equal to that square area times pi, well, like 3.14 times bigger, because it's like one. Well, take the square or half of that, and you'll find out how many times each hemisphere increased the surface area there. Okay, thank you.